Okay, so this is May-June 2017. We're in 5-1. Question number 1, last part. So in this, the last part, they say that the student found that the value for the enthalpy change of solution of anhydrous calcium chloride is minus 82.5. The minus in with 82.5 shows us that the reaction is exothermic, right? And the enthalpy change of solution is when you dissolve 1 mole of your solid into your solvent, and then you see the heat change or the enthalpy change, right? And the manufacturer produces a heat pack that contains 75 grams of water, and we're supposed to calculate the mass of anhydrous calcium chloride that the manufacturer must use in the inner bag to produce a rise in temperature of 30 degrees Celsius. So what they're basically saying is that this is our heat pack. This is our heat pack, okay, and it has obviously water, and the weight of the water is 75 grams, okay, and we know for a standard equation that CO2 dissolves in water, this is solid, to give us calcium 2 plus ions plus 2 chloride negative ions, and both of these are aqueous. Okay, so we know that 1 mole of calcium chloride, okay, this particular reaction gives us the energy of, or enthalpy change of, minus 82.5. So when we have 1 mole of calcium chloride, we get minus 82.5. So if we make a ratio of mole to our delta H, so if we have 1 mole of it, then we have 82.5. Okay, so what they're basically saying is that the manufacturer, we know that 1 mole is going to give us enthalpy change of minus 82.5, and we know that the manufacturer has 75 grams of water inside of it. Now what they want to know is that we have the smaller bag, okay, the inner bag, and obviously it's going to have our calcium chloride. So what the question is asking is that how much of calcium chloride we need in this inner bag so that when it ruptures and the reaction proceeds, we get a temperature rise of 30 degrees Celsius. So they're basically asking what mass do we need. Okay, so I'm just gonna clean this up a bit, or maybe I can find some place over here. Okay, so first of all, we know that 1 mole is going to produce 82.5 of energy, but they're asking over here for the they're asking us for the mass of anhydrous calcium chloride that the manufacturer needs, not the moles of calcium chloride. So instead of moles over here, I'm going to calculate the mass. So basically we're just gonna see mass. So we're gonna see how much mass 1 mole of calcium chloride has. So how can we find this mass? Obviously we're gonna take the MR of calcium chloride. Okay, and we have some of the values already with us, that calcium is 40.1 and chlorine is 35.5. So for calcium we're going to take 40.1 into 35.5 into 2, sorry, wait a sec, this isn't supposed to be multiplied, it's supposed to be added. The mass for chlorine and the mass for calcium are supposed to be added, not multiplied. So we have 40.1 for calcium, and for chloride we have 35.5 into 2 because we have 2 chlorines, and we're gonna add these up and we're gonna get 111.1 grams. Okay, so this is the mass that is going to give us 82.5 of enthalpy change. But the enthalpy change that we get if there's a temperature rise of 30 degrees Celsius and there is 75 grams of water. So what is the temperature change then if we have 75 grams of water and we need a temperature of 30 degrees Celsius? So we're going to calculate that heat energy that we get when we have 75 grams of water. So we're gonna go like Q is equals to MC del theta, or we can have MC del T. So M is 75, RC specific heat capacity value for water is 4.18, and our del T is, or del theta is 30 degrees. So we get 9405 joules. Okay, let me clean this up a bit. Okay. So now obviously the value is in joules, and in standard, when we're doing calculation, we use our standard units, so we're going to convert it into kilojoules. So it will be 9405 divided by 1000. So we get 9.405 kilojoules. Okay, so now if I mass ratio delta H, or energy, or whatever you want to call it, and I'm just going to simply transfer whatever I wrote over here. Okay, so if we have 1 mole of calcium chloride, like we do in our equation where we get our enthalpy change of solution from, 1 mole, which has a mass of 111.1 grams, we get an enthalpy change of 82.5, correct? But over here, when we have our we have 75 grams of water and 30 degree Celsius rise, then we don't get 82.5 kilojoules. we don't get this. We get, instead of it, we get this value of 9.405, right? Kilojoules. So we know for 1 mole or a mass of 111.1 grams, we have this value of 82.5. But if we use 30 degrees Celsius and 75 grams of water, we get this value of 9.405 kilojoules. And that's what they're asking. They're asking that if this is the condition, 30 degrees Celsius and 75 grams of water, so the energy produced, okay, so for that energy, how much mass we'll need? So obviously that will be X. And now we just simply have to calculate X, which would be X is equals to, we'll cross multiply them. So it will be 9.405 into 11.1 divided by 82. Okay, and we do all of this calculation, we get this as our final answer, 12.7 grams. 12.7 grams. So this 12.7 grams is our final answer. And we did it. We're done with question number 1 of this past paper, and question number 2 is left. We're going to do it in the next video. So hopefully you understood all of this calculation and stuff. So if you did not, you can ask in the comments and I'll reply.